Good morning, fifth grade. I hope you are having a good week. I'm going to start by going over the follow-up question from last time. As you remember, this is our King Henry chart, and we know the my in the middle stands for meter, the C for chocolate stands for centimeter, the M for milk stands for millimeter, and the K for king stands for kilometer. So we want to convert 6 centimeters to millimeters. So I'm going to put a 6 under the centimeters, and I'm going to millimeters. It's moving one spot down, so it is 10 times smaller, in which case 6 centimeters is the same as, is the same as 60 millimeters. Now, just so it's not going to get confusing, I'm going to erase this. Now I have 500 centimeters. And I'm want to convert it to meters. So I'm going up 2 spots. That's times 10 times 10, which is 100. So it's 100 times bigger. Because the unit of measure is bigger, we need less of it. So it's the opposite. It's like dividing. So we're doing 500 divided by 100, which gives me 5 meters. Okay, nice job. All right, let's look at the bonus question that some people did. Remember, our King Henry chart is the same, and you should draw it out every time you're going to solve a problem. Heriberto is trying to estimate the distance of his walk to school. He measures his steps and finds that he travels about 60 centimeters in one step. One day he walks to school and his Fitbit says that he took 1,800 steps. About how far is the walk to school in kilometers? So we're in centimeters, okay? It's 60 centimeters in one step, so we took 1,800 steps. So first we gotta multiply to find our total amount of steps in centimeters. So 60 times 1,800. So I could do a couple of things to make this easier. I could do 6 times 18, which is 108. And then I can count how many zeros I need to add on. 1 from the 60, 2, 3. So I have 108,000 centimeters. And we're trying to go all the way to kilometers. So I think we should do this in 2 parts. Let's first go to meters. So meters is 2 spots up. It's almost like 2 place values up. So it is times 10 times 10. Or if we put the 10s together, 100 times larger. Since 100 times larger, meters take up more space, that actually means we are going to divide. So in this case, I can take 108,000 and divide it by 100. Well, this is pretty easy. I could eliminate 2 zeros, and I see how many meters I have, which at this point would be 1,080 meters. Okay, so now I'm at meters. Now I need to get about how many kilometers is that. So let's see, how many spots am I moving up from meters to kilometers? Let's count. 1, 2, 3. That's like going 3 place values up. Okay, so times 10 times 10 times 10, right? Which 10 times 10 times 10 is 1,000. But since kilometers since kilometers are a lot bigger than meters, we need to think about how many do we need. So we're going to need fewer than the meters. So we're actually doing the opposite. It's 1,000 times bigger, which means we need to divide. So I'm writing out 1,080 divided by 1,000. So what could we do that's easy first? Well, I could eliminate 1 0 from each part. And now I have 108 divided by 100. Now, if I do that, I need to think, how many place values am I shifting this number? So think about this like I could make a place value chart. I'm kind of running out of space out here. But if I had 108, oops, let's do it a little bit more so I have more space. 108, and this is the ones, tens, and hundreds. And I'm dividing by 100. I'm shifting it down 2 place value spots. So if this is the decimal, shifting the 8 down 2 spots, the 0 down 2 spots, and the 1 down 1 spot, 2 spots. So approximately how many kilometers does it take Heriberto to walk to school? You see my 8 in the ones place, move to the hundredths place. My 0 in the tens place, move to the tenths place. My 1 in the hundreds place, move to the ones place. So approximately about how far is the walk to school in kilometers? 1 and 8/100ths of a kilometer. So using place value is really helpful for this entire problem, okay? All right, so today we're gonna move on to another part of measurement where we talk about mass or weight, or like how much something weighs. And we're talking about the customary system, so how we measure things in the United States. When we think of mass and weight, they're a little bit different, but for these examples, we're going to use the words interchangeably. When you think of the mass of something, you might think of science weighing it on a scale, like the one I have in the corner, or you think of weight, like stepping on the scale in your house to see how much you weigh. So there are 3 units of measure in the customary system for mass and weight. The first is 1 ounce, which is really light. It's used to measure things that are not very heavy, and it's about the weight of 1 strawberry. 1 pound is about about the size of a box of spaghetti, or how much 1 box of spaghetti weighs. And the abbreviation for pounds is LB, which is kind of confusing because it should be P, like for pounds, but the way I have people remember it is if you know what pound means in Spanish, libra, then it's very similar because you see the same letters, okay? 1 ton, which is used for really, really heavy things, is like the weight of a baby elephant or a small car. So in order from smallest to biggest, or from the lightest to, can't spell today, the lightest to heaviest, I have ounces, pounds, and tons. And if I go the other way, starting at the heaviest, I have tons, pounds, and ounces. So here's what I would like you to do. I have a bunch of objects here, and I want you to think about what unit makes sense to weigh these objects in. I'm going to go ahead and give you a couple minutes to figure this out. It is possible there could be more than one answer. All right, should we try it? The weight of a piece of paper is pretty light. I would weigh that in ounces. The weight of a rhinoceros, I'm trying to think, a rhinoceros is a huge animal, kind of like an elephant. I would weigh that in tons. The weight of a textbook, depends on how heavy the textbook is, but I think I would do it in pounds. But I could see that if it's a light textbook, you might use ounces. The weight of a person, I would use pounds. Think about it. When you go on the scale at the doctor's, they weigh you in pounds. The weight of your desk, I would say pounds. I have the weight of a person again. We know that's pounds. The weight of a ring, I would say ounces. A ring is pretty light. The weight of a penny. Penny is also pretty light. I would say ounces. The weight of a pencil. I would say ounces. And the amount of medicine in a Tylenol pill, that's pretty small. I would say ounces. Okay? Now let's practice. I'm going to read these 3 questions and give you a moment to make your choices before we go over it. What is the most likely weight of a hardcover textbook? 1 ounce, 5 ounces, 2 pounds, or 10 pounds? Which item could be measured in pounds? The weight of a bowling ball, the weight of a cotton ball, the weight of a sheet of paper, the length of a football field. The mass of the banana, do we think it's 5 kilograms, 5 ounces, 5 pounds, or 5 cups? Go ahead and make your choices. All right, what is the most likely weight of a hardcover textbook? 10 pounds is way too much. Some textbook. 1 ounce is too light. 5 ounces, I would agree, is too light. I would say about 2 pounds. Which item could best be measured in pounds? Well, the length of a football field, that's distance, so that doesn't even count as weight. Sheet of paper is pretty light, and so is a cotton ball, so I would measure those in ounces. So I would say the weight of, of a bowling ball. The mass of a banana, would I say 5 kilograms, 5 ounces, 5 pounds, or 5 cups? I would probably say about 5 ounces. Pounds are too heavy. Okay, let's try 3 more. Which item would best be measured in tons? A dog, a building, an ant, or a cat? Next question. Miss K was making chili for dinner. She was measuring out the mass of a bunch of spices. What unit of measure would be the most appropriate? To determine the weight of the furniture in a classroom, the furniture should be weighed in. I'll give you a second to kind of figure it out. All right, which item would best be measured in tons? Remember, tons is for extremely heavy things. An ant, I would measure in ounces. A dog and cat, like a human, I would measure in pounds. So a ton, I would choose the building. Miss K was making chili for dinner. I'm measuring out all these spices. I want to know how much the spices weigh. I would probably use ounces. So you don't put that much of each spice in it. Think about it. A pound of pepper is a ton of pepper. That would be not appropriate for that. To determine the weight of the furniture in a classroom, the furniture should be weighed in pounds. So here is our reflection based on what we learned for today. To measure weight and mass in the customary system, the units of measure we use are ounces, pounds, and tons. Ounces are used to weigh items that are very light, like spices when you are cooking. Pounds are the most common unit of measure used to weigh people and most things. Tons are used to weigh extremely heavy objects. Think cars, trucks, construction vehicles, buildings, very, very large animals. So here's your follow-up question, and it's kind of like what we did when we were measuring distance. For your follow-up question, please walk around your house or outside and come up with items you would weigh using ounces, pounds, and tons. Please explain why you would use those measurements. Feel free to take pictures of the item as well and send them to me. If you do, by the end of the week, I will be sure to put the pictures in my video for next week. Questions. If you have any questions about what I talked about in the video, please let me know by emailing me your responses or messaging me on Dojo. Also, remember, all of you have a Google Meets meeting with me sometime this week. Can't wait to see you there. Miss you guys. Bye. After a run this morning in this very, very hot weather, not very husky-like, I wish I was in Alaska with snow. I am taking a nap while you all do math.